March 7, 1945. Kummersdorf Proving Grounds, 25 kilometers south of Berlin. The morning air carried the acrid smell of diesel exhaust mixed with cordite residue from the previous day's firing tests. Hauptmann Klaus Weber stood beside a captured American tank that bore fresh Balkenkreuz markings hastily painted over faded white stars. The machine before him represented everything German tank doctrine had dismissed as industrially crude. Yet something about this particular Sherman troubled him in ways he could not immediately articulate. The tank was an M4A3E8, what American soldiers had begun calling the Easy 8. German intelligence had intercepted communications referring to this designation during recent engagements along the Siegfried Line. Serial number stamped on the hull plate read 3089776. Recovery teams had extracted this specimen from a battlefield near Echternach in Luxembourg just 3 weeks earlier following the chaotic conclusion of the Ardennes offensive. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The crew had abandoned the vehicle after a track was damaged by a Teller mine, leaving the tank otherwise intact and fully operational, once German engineers replaced the track assembly with components cannibalized from other wrecked Shermans. Weber had commanded Panzer IVs in France during 1940 and later Tigers on the Eastern Front, until a shoulder wound at Kursk relegated him to testing duties at Kummersdorf. He understood tanks through direct combat experience rather than theoretical study. The war had taught him to respect Soviet T-34 seconds for their robust simplicity and to fear the proliferation of American equipment that seemed to arrive in endless quantities, regardless of how many were destroyed. But nothing in his experience had prepared him for what he was about to discover about American engineering philosophy. The testing program at Kummersdorf had examined numerous captured Sherman variants throughout the war. The facility's comprehensive reports documented armor thickness, mobility characteristics, automotive reliability, and armament effectiveness. German engineers had systematically disassembled engines, studied transmission designs, and evaluated every measurable aspect of American tank construction. Their conclusions consistently noted American emphasis on production efficiency and mechanical reliability over the performance optimization that characterized German designs. Earlier, Sherman models had impressed German evaluators with their automotive dependability and surprising comfort for extended operations. The Ford GAA V8 engine produced 500 horsepower and demonstrated remarkable consistency across thousands of production examples. American crews operated tanks equipped with standardized components manufactured to tight tolerances, using materials that Germany increasingly lacked access to as strategic bombing degraded industrial capacity. But the assessment remained that American tanks represented adequate rather than exceptional designs, produced in overwhelming quantities to compensate for qualitative limitations. The M4A3E8 sitting before Weber represented the latest evolution of Sherman design. The designation indicated several significant modifications from earlier variants. The A3 specified the Ford GAA engine. The 76 indicated the new high-velocity 76mm M4A3E8 gun that finally approached the penetration capability of German weapons. The W referred to wet ammunition storage, a fire suppression system that significantly reduced the catastrophic ammunition fires that had earned Shermans their grim reputation among German tank crews. The E8 denoted the new horizontal volute spring suspension system with wider 23-inch tracks that dramatically improved ground pressure and cross-country mobility. Production of the Easy 8 had begun in August 1944 at the Detroit Tank Arsenal and Fisher Tank Arsenal. American factories had manufactured approximately 2,600 examples by March 1945, with production continuing at a rate that exceeded the combined output of all German tank types. These new Shermans had first appeared in combat during December 1944 at the Battle of the Bulge, where their improved mobility through snow and mud gave American forces advantages during desperate defensive operations. Weber walked slowly around the captured tank, noting details with professional interest. The welded hull construction showed consistent quality throughout all visible welds. The wider tracks demonstrated American willingness to accept increased manufacturing complexity to improve tactical performance. The 76mm gun extended from a redesigned T-23 turret that provided better protection and more internal space than earlier Sherman turrets. Every visible component suggested thoughtful engineering rather than the hasty compromises that increasingly plagued German late-war production. But the feature that would fundamentally challenge German understanding of American capabilities remained invisible during external inspection. The gun stabilization system represented technology that German engineers had attempted to develop without achieving practical implementation in production tanks. American designers had equipped Sherman tanks with gyroscopic stabilizers since early production models, though the complexity of the system and inadequate crew training had led many American units to disable the mechanism during the war's early years. The stabilizer concept was straightforward in principle, but extraordinarily difficult to implement reliably. A gyroscope maintained a reference plane regardless of vehicle movement. Hydraulic systems pulled power from the turret traverse mechanism to physically move the gun in elevation to compensate for hull movement, keeping the weapon aimed at its target despite the tank pitching and rolling over uneven terrain. The system operated only in the vertical plane. Horizontal aiming still required manual turret traverse. But even single-plane stabilization represented a massive advantage for crews who understood how to properly utilize the technology. German tank designers had studied gyroscopic stabilization concepts throughout the war. Theoretical papers circulated through engineering departments at Daimler-Benz, MAN, and Porsche. Experimental programs attempted to develop practical systems, but the complexity of manufacturing precision gyroscopes, the challenge of creating reliable hydraulic control systems, and the shortage of specialized materials required for components that could withstand combat conditions had prevented implementation in production vehicles. The technology remained theoretical for German forces, while Americans had installed working stabilizers in thousands of tanks as standard equipment. Weber climbed onto the EZ-8's hull and carefully lowered himself through the commander's hatch into the turret. The interior immediately struck him as spacious compared to German tanks he had commanded. The turret ring diameter of 69 inches provided substantial working volume. American designers had optimized internal layout for crew efficiency rather than minimizing external dimensions. Storage racks were logically positioned. Ammunition stowage surrounded by liquid-filled jackets to prevent fires occupied the hull floor where penetrating shots were least likely to strike. Controls were clearly marked and positioned within comfortable reach. The gunner's station featured a coincidence rangefinder sight and the controls for the gun stabilization system. Weber examined the stabilizer controls carefully. A simple on-off switch activated the system. Indicator lights showed gyroscope status and hydraulic pressure. The design philosophy emphasized operational simplicity for crew members who might have limited technical training. German systems tended toward a complexity that demanded skilled operators and frequent maintenance. American equipment prioritized reliability and ease of use, even if this meant accepting some performance limitations. Oberleutnant Friedrich Steinmetz, the facility's senior automotive engineer, approached the tank carrying a clipboard thick with testing protocols. Steinmetz had evaluated captured Allied vehicles throughout the war and maintained professional objectivity despite the increasingly desperate strategic situation. His reports documented American and British equipment capabilities with technical precision that sometimes troubled Kummersdorf's military leadership when findings contradicted official assessments. "The preliminary inspection is complete, Hauptmann," Steinmetz reported. "The tank is mechanically sound. The engine runs smoothly. All systems appear functional, including the stabilization mechanism. We can begin mobility trials this afternoon, followed by firing tests tomorrow morning." Weber nodded. "What do you make of this model compared to earlier Shermans you've examined?" Steinmetz consulted his notes. "The suspension system represents a significant improvement. The wider tracks reduce ground pressure to levels comparable to our Panthers despite the Sherman's weight. The automotive components show the same high manufacturing quality we've observed in previous American vehicles. The 76mm gun finally gives them adequate anti-armor capability, though still inferior to our long 88s. The stabilizer system appears to be a refined version of earlier designs with simplified controls. Have you tested the stabilizer on previous Shermans? We examined the mechanism on several earlier models, Steinmetz replied. The system was functional when properly adjusted, but many American crews apparently disabled it due to complexity and inadequate training. The controls on this variant appear simplified. I suspect the Americans improved both the hardware and their reponed training procedures. Weber considered this. German intelligence reports from the Western Front mentioned increasing American tactical proficiency during late 1944 and early 1945. American tank crews were demonstrating better coordination, more aggressive tactics, and improved marksmanship. Perhaps better training extended to utilizing the equipment capabilities their tanks possessed. The testing program followed established Kummersdorf protocols. Steinmetz's engineers conducted comprehensive automotive trials across the facility's proving grounds. The EZ-8 demonstrated excellent cross-country mobility. The HVSS suspension absorbed terrain irregularities smoothly while maintaining stable hull attitude. Track tension remained consistent during sharp turns. The Ford GAA engine responded predictably across its power range. Steering required reasonable physical effort without the excessive force demanded by some German tanks. Everything about the EZ-8's mechanical performance confirmed what German evaluators had observed about American engineering priorities. The tank was not optimized for absolute maximum performance in any single category. American designers had instead created a balanced system that performed adequately across all requirements while maintaining reliability and ease of operation. This philosophy produced tanks that average crews could operate effectively under field conditions, rather than demanding exceptional skill to extract theoretical capabilities. But the revelation came during gunnery trials when Weber personally tested the stabilization system under realistic conditions. He positioned himself in the gunner's seat while Steinmetz operated the tank across rough terrain at the Proving Grounds tank course. The course featured ditches, berms, and obstacles designed to simulate battlefield conditions. Weber activated the stabilizer and aimed the 76mm gun at a stationary target board, positioned 1,000 meters distant. The sensation defied his expectations completely. As the Sherman pitched and rolled over the uneven ground, the gun remained steady in elevation as if held by invisible hands. The reticle in his sight stayed fixed on the target despite violent hull movement. When the tank dropped into a ditch, the gun elevated automatically to compensate. When they climbed over a berm, it depressed to maintain aim. The hydraulic system responded instantly and smoothly to keep the weapon on target. Weber had experienced many things in tank combat. He understood the chaos of moving while engaging targets. Every German tank commander knew the frustration of losing aim when the tank hit rough terrain. Standard procedure required stopping to fire accurately. Moving tanks fired wildly with minimal hit probability. The Americans had apparently solved this fundamental problem through engineering rather than tactics. He pressed the firing button. The gun discharged. Through the sight, Weber watched the tracer arc toward the target and impact directly on the aiming point despite the tank's movement. He fired again while Steinmetz maintained speed across broken ground. The second round struck within inches of the first. A third shot. Another hit. The impossible was happening repeatedly and consistently. Weber ordered Steinmetz to stop the tank. He needed to process what he had just experienced. The implications extended far beyond a clever mechanical system. This technology fundamentally altered the tactical equation of tank combat in ways that favored the side that possessed it. The stabilizer actually works, Weber said quietly to Steinmetz after climbing out of the tank. Not just theoretically, it works precisely and reliably under realistic conditions. Steinmetz nodded. I observed the results. The system maintained gun elevation throughout the course. I've never seen anything comparable in German tanks. Because we don't have anything comparable, Weber replied. We've never successfully implemented this technology in production vehicles. The Americans have equipped thousands of tanks with working stabilizers and trained their crews to use them effectively. The two men stood silently for a moment, contemplating the implications. The war had turned decisively against Germany. Everyone at Kummersdorf understood this reality, regardless of official propaganda. But discovering that American forces possessed technological advantages in addition to overwhelming numerical superiority made the strategic situation even more hopeless than previously assessed. Weber ordered additional testing over the following days. Different gunners fired the stabilized 76mm gun under various conditions. Every trial confirmed the same conclusion. The stabilization system worked exactly as designed when crews understood how to operate it properly. The Americans had created a significant tactical advantage through engineering sophistication that German forces could observe and measure, but not replicate. The technical explanation for why the stabilizer mattered became clear through systematic analysis. Tank gunnery involved complex variables. The gunner needed to estimate range, calculate lead for moving targets, compensate for ammunition ballistics, and account for environmental factors like wind. But the most fundamental requirement was keeping the gun aimed at the target long enough to fire accurately. Traditional tank doctrine required stopping to shoot because maintaining aim while moving was essentially impossible. The vehicle's suspension transmitted every bump and irregularity directly to the hull. The gun mount fixed rigidly to the turret pitched and yawed with hull movement. Gunners physically could not keep the reticle on target when the tank moved across realistic terrain. Stopping solved the problem but created a different vulnerability. A stationary tank presented an easy target for enemy guns. The stabilizer transformed this tactical dilemma. American tanks could maintain accurate aim while moving, engaging targets during approach, then firing the instant they reached optimum range without pausing. This capability offered multiple advantages. The tank remained a moving target that was harder to hit. The crew could fire sooner rather than stopping short of ideal range. If the first shot missed, the tank could continue moving while adjusting aim for subsequent shots rather than remaining stationary. Perhaps most importantly, the stabilizer dramatically reduced the time between identifying a target and firing the first shot. When a Sherman stopped after moving, the gun was already approximately on target rather than wildly off aim. The gunner only needed minor adjustments before firing. German tanks required the gunner to completely relay the gun after stopping because movement had thrown off the previous aim. Those extra seconds often determined who fired first, and firing first usually meant surviving the engagement. Weber understood tank combat viscerally. He had experienced the desperate rush to fire before the enemy. He knew how target acquisition and engagement unfolded under combat stress. The stabilizer addressed fundamental problems that every tank crew faced regardless of nationality or equipment. The Americans had engineered a solution, the Germans had not. Kummersdorf's evaluation continued for 3 weeks. Engineers created detailed technical reports documenting every aspect of the M4A3E8's capabilities. The stabilizer received special attention. Steinmetz's team disassembled components to understand the manufacturing techniques. They examined the gyroscope assembly, studied the hydraulic control system, and measured the precision of machined parts. The gyroscope itself represented sophisticated manufacturing. The spinning mass required perfect balance. The mounting system needed to isolate the gyroscope from vehicle vibration while remaining responsive to actual orientation changes. The electrical system that powered the gyroscope demanded reliable components that German production increasingly struggled to manufacture as material shortages worsened. Every element of the stabilizer reflected careful engineering and quality manufacturing. The hydraulic control system demonstrated similar sophistication. Fluid pressure had to remain constant under varying conditions. Seals needed to prevent leaks that would cause system failure. The linkages connecting hydraulic actuators to the gun mount required precise manufacturing to minimize backlash and ensure responsive control. American factories had produced these systems to consistent standards across thousands of tanks. German industry could not replicate this achievement, given current resource constraints and strategic circumstances. The report Steinmetz prepared for distribution through German armored forces. Technical services acknowledged capabilities that contradicted comfortable assumptions. American tank designers had successfully implemented advanced technology that improved tactical effectiveness. The EZ-8 represented refined engineering rather than crude mass production. The stabilizer was not experimental equipment but standard installation functioning reliably in field conditions. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Weber contributed tactical assessment to supplement Steinmetz's technical analysis. He emphasized how the stabilizer altered engagement dynamics. German tank crews had trained on doctrine that emphasized stopping to fire accurately. This doctrine reflected equipment limitations rather than tactical preference. American crews could engage while moving, firing accurately at speeds up to 15 miles per hour under favorable conditions. This capability fundamentally changed how tank combat unfolded. German tankers could no longer assume that American Shermans would stop before firing. The EZ-8 might engage during approach, potentially getting off the crucial first shot before German crews had even aimed their guns properly. The stabilizer did not make Shermans invulnerable. A well-aimed shot from a Panther or Tiger would still destroy an EZ-8. But the technology reduced German tactical advantages while amplifying American numerical superiority. The revelation that Americans had successfully implemented gyroscopic stabilization in mass-produced tanks forced uncomfortable acknowledgement within German technical circles. Several German firms had explored stabilization concepts throughout the war without achieving practical implementation. Daimler-Benz had conducted theoretical studies. Engineering departments at MAN and Henschel had drafted proposals. But the technical challenges proved insurmountable given resource constraints and manufacturing limitations that plagued German industry by 1944. Gyroscopic stabilization required precision components manufactured to tolerances that German factories struggled to maintain as strategic bombing degraded production capacity. The gyroscope itself demanded perfect balance and specialized bearings. The hydraulic control system needed reliable seals and consistent fluid pressure under varying temperatures and combat conditions. The electrical power supply had to function consistently despite vehicle vibration and battle damage. Every component had to work together as an integrated system, and failure of any single element would disable the entire mechanism. German engineers examining the EZ-8's stabilizer understood the theoretical principles perfectly. They recognized the manufacturing sophistication required for reliable implementation. They acknowledged the tactical advantage the system provided. But they also understood with absolute certainty that Germany lacked the industrial capacity to replicate this technology in production vehicles given current strategic circumstances. The materials required for stabilizer components were increasingly scarce. High-grade steel for precision bearings had become difficult to obtain as Allied bombing disrupted German steel production and cut access to Swedish imports. Copper for electrical components was rationed strictly for priority applications. Rubber for hydraulic seals deteriorated in quality as synthetic substitutes replaced natural rubber that Germany could no longer import. Even basic manufacturing supplies like cutting tools and precision measuring instruments were becoming scarce. The skilled workforce necessary for manufacturing complex systems had been steadily depleted. Experienced machinists had been drafted into military service and replaced by forced labor with minimal training. Quality control had deteriorated across German industry as production pressures increased and oversight resources diminished. The Americans apparently maintained manufacturing standards even while expanding production to unprecedented levels. Germany was losing the capacity to manufacture complex equipment, even as demand increased desperately. Weber's report to Kummersdorf leadership concluded with stark assessment. The M4A3E8 represented the most refined Sherman variant German forces had encountered. The combination of improved mobility from HVSS suspension, adequate anti-armor capability from the 76mm gun, enhanced survivability from wet ammunition storage, and tactical flexibility from the gun stabilizer created a tank that was significantly more dangerous than earlier Sherman models. The stabilizer specifically concerned Weber because it addressed a fundamental problem that affected all tanks equally, regardless of design, sophistication, or crew skill. Every tank commander understood that firing while moving meant missing the target. The Americans had engineered a partial solution to this universal challenge. German tanks retained advantages in armor protection and gun performance. The Panther's 75mm KBUK 42 litres, 70 gun penetrated more armor at longer ranges than the Sherman's 76mm. The Tiger's 88mm KWK 36 outclassed anything the Americans fielded. But gun performance mattered less if German tanks could not bring their superior weapons to bear before American tanks fired first. The strategic implications extended beyond individual tank capabilities. American forces were deploying EZ-8s in increasing numbers during early 1945. Intelligence reports indicated hundreds of the new model had reached Europe by March. Production was continuing at rates that would eventually equip significant portions of American armored divisions with the upgraded tanks. German forces could expect to encounter EZ-8s with growing frequency as the war progressed. Steinmetz's technical team completed their evaluation of the EZ-8 in late March 1945. The comprehensive report documented every measurable aspect of the tank's performance. Armor thickness and angles were recorded precisely. Mobility characteristics across various terrain types were quantified. Automotive reliability was assessed based on extended operation. The stabilization system received detailed analysis, including photographs of disassembled components and technical drawings showing internal mechanisms. The report circulated through German Armored Forces Technical Services, along with tactical recommendations for engaging EZ-8s in combat. German tank commanders were advised that stabilizer-equipped Shermans could fire accurately while moving at speeds up to 15 miles per hour under favorable conditions. German crews should expect American tanks to engage during approach rather than stopping to aim. The crucial first-shot advantage that German tankers had relied upon might no longer exist when facing EZ-8s operated by well-trained crews. The tactical advice acknowledged realities that contradicted comfortable assumptions. American equipment was not crude or unsophisticated. American tank crews were not poorly trained. American industrial capacity was not simply producing vast quantities of adequate equipment. The United States had designed genuinely capable tanks, manufactured them to consistent quality standards in enormous numbers, and trained crews to utilize the equipment effectively. Germany faced opponents with both quantitative and qualitative advantages in armored warfare. German tank crews who read Kummersdorf's reports during spring 1945 understood they were receiving information that arrived too late to matter strategically. The war was clearly lost by March. Soviet forces were advancing from the east. American and British armies were pushing through Germany from the west. German industrial capacity had collapsed under relentless bombing. Fuel shortages immobilized vehicles. Ammunition supplies dwindled. Experienced crews had been lost to attrition faster than replacements could be trained. Knowledge that American Shermans possessed working gun stabilizers provided little practical benefit when German tanks lacked fuel to maneuver, ammunition to shoot, or replacement parts to repair battle damage. The stabilizer represented just one more American advantage among many that German forces could observe and understand, but not counter given their deteriorating situation. But for tankers still fighting desperate defensive actions across Germany, the information had immediate relevance. Understanding what EZ-8s could do helped crews develop tactics that might improve survival odds slightly. German tank commanders learned to assume that American Shermans might fire accurately while moving and to plan accordingly. They understood that relying on the traditional doctrine of stopping to fire while assuming opponents would do likewise, was no longer valid when facing stabilizer-equipped tanks. The experience of German test pilots flying captured P-51 Mustangs had demonstrated American aeronautical engineering sophistication. The evaluation of captured Republic P-47 Thunderbolts had revealed American industrial capacity to implement complex technology like turbo superchargers as standard equipment. Now, the systematic testing of the M4A3E8 Sherman confirmed that American advantages extended across all categories of military equipment. Aircraft, tanks, trucks, radios, and optical instruments all demonstrated consistent quality and thoughtful engineering. The broader pattern was impossible to ignore for professionals like Weber and Steinmetz, who evaluated enemy equipment objectively. America possessed industrial capacity that exceeded German capabilities by factors that made competition impossible. American factories produced equipment designed by competent engineers, manufactured by skilled workers using adequate materials, assembled to consistent standards, and delivered to military forces in quantities that overwhelmed opposition through sheer abundance. Germany had attempted to compete through engineering excellence and tactical innovation. Panther and Tiger tanks demonstrated sophisticated design that maximized performance within weight and manufacturing constraints. German tank crews had developed effective tactics through hard combat experience. Individual German tankers often possessed superior skill compared to American counterparts, but these advantages proved insufficient against opponents who combined adequate equipment with overwhelming numerical superiority and growing tactical proficiency. Weber understood tank warfare intimately through direct combat experience on both the eastern and western fronts. He had commanded Tigers at Kursk, where German heavy tanks had dominated Soviet armor through superior gun performance and crew training. He had witnessed the gradual shift in battlefield dynamics as Soviet production overwhelmed German forces through numerical advantage despite German technical superiority. Now he observed the Western Allies achieving similar dominance through industrial capacity that exceeded even Soviet production. The Americans were not simply outproducing Germany, they were simultaneously improving equipment quality while expanding production quantities. Early war Shermans had been adequate tanks with significant limitations. The M4A3E8 represented systematic refinement that addressed earlier weaknesses, while maintaining the automotive reliability and manufacturing efficiency that characterized American design philosophy. The progression from early M4 variants to the EZ8 demonstrated continuous improvement rather than desperate improvisation. German tank development followed a different trajectory during the same period. The Panther had entered service in 1943 as a sophisticated response to the Soviet T-34. The Tiger I had provided heavy breakthrough capability, but both designs suffered from complexity that made them difficult to manufacture in adequate numbers and challenging to maintain under field conditions. Later variants attempted to address these problems without sacrificing performance, but resource shortages and production disruptions prevented effective implementation. The Tiger II represented German efforts to combine the Tiger's firepower with the Panther's sloped armor. The result was a formidable tank that could destroy any Allied vehicle at extreme ranges, but the Tiger II weighed nearly 70 tons, powered by the same Maybach engine used in the much lighter Panther. The power-to-weight ratio produced inadequate mobility. Mechanical reliability remained problematic. Production numbers stayed minimal due to manufacturing complexity and Allied bombing of component suppliers. German tank designers had created vehicles optimized for absolute maximum performance in specific categories. The Tiger II's frontal armor was virtually impenetrable by Allied tank guns under combat conditions. The long 88mm K-43 gun could penetrate any Allied tank frontally at ranges exceeding 2 kilometers. These capabilities were genuine and significant, but they came at the cost of mobility, reliability, and producibility that made the Tiger II strategically irrelevant despite its tactical potency. The Americans had designed Shermans for different priorities: adequate rather than maximum armor protection, sufficient rather than overwhelming firepower, automotive reliability over theoretical performance, ease of maintenance under field conditions, manufacturing efficiency that enabled mass production. Every design decision reflected understanding that availability mattered more than theoretical superiority. 1,000 adequate tanks delivered to the front line provided more combat power than 100 superior tanks if the superior tanks remained in factories waiting for scarce components. The EZ8 embodied this philosophy in refined form. The HVSS suspension improved mobility without requiring complete redesign. The 76mm gun provided adequate anti-armor capability without the manufacturing complexity of heavier weapons. The wet ammunition storage reduced fire risk through straightforward engineering rather than sophisticated fire suppression systems. The stabilizer enhanced tactical flexibility using technology American industry could manufacture reliably at scale. Weber recognized that comparing individual tanks in isolation missed the essential strategic reality. The question was not whether a Panther could defeat an EZ-8 in single combat under favorable conditions. German crews with superior training in well-maintained Panthers would likely prevail in such engagements. The relevant question was whether Germany could field enough Panthers with adequate fuel, ammunition, and trained crews to counter the thousands of EZ-8s, earlier Shermans, Soviet T-34 seconds, and British Cromwells that Allied forces deployed. The answer to that question had been negative since at least mid-1944, when German industrial production peaked, then began declining under relentless Allied strategic bombing. German tank production had reached approximately 400 units monthly during summer 1944, including all types from Panzer IVs through Tiger IIIs. American tank production exceeded 1,500 units monthly during the same period. When combined with British and Soviet production, Allied advantages in armoured vehicle manufacture exceeded 4-1 by the war's final year. The stabilizer represented just one element of comprehensive American advantage. German tankers faced opponents who possessed more tanks, more fuel, more ammunition, more replacement vehicles when tanks were destroyed, more spare parts for maintenance, better logistics support, and increasingly effective tactical training. The stabilizer added one more capability to this overwhelming list. American tank crews could now fire accurately while moving, gaining precious seconds in combat engagements where seconds determined survival. By April 1945, Kummersdorf was evacuating equipment and personnel ahead of advancing Soviet forces. The facility that had systematically evaluated captured Allied equipment throughout the war faced abandonment as the Red Army closed on Berlin from the east. The EZ-8 Weber had tested so thoroughly would likely be destroyed or captured within weeks. The comprehensive reports documenting American tank capabilities would be scattered or lost in the chaos of Germany's final collapse. Weber received orders to destroy sensitive documents and withdraw toward American lines, where surrender to Western allies might offer better prospects than capture by Soviet forces. Steinmetz and his engineering team prepared to flee with whatever technical materials they could transport. The knowledge they had accumulated about Allied equipment through systematic evaluation would survive primarily in their memories, rather than organized archives. The final irony was that German engineers had understood American capabilities more accurately than American commanders sometimes did. Kummersdorf's reports on Sherman tanks documented strengths and weaknesses with professional objectivity. German tankers who had fought Shermans in combat could describe American tank performance in precise detail. This knowledge provided tactical advantages in individual engagements, but could not overcome strategic disadvantages that made German defeat inevitable regardless of tactical proficiency. The EZ-8 would continue serving American armored forces through the war's conclusion in May 1945. The tanks participated in final offensives across Germany and into Czechoslovakia. After Germany's surrender, EZ-8s remained in service with American occupation forces. The design proved successful enough that the tanks later saw extensive combat during the Korean War, where HVSS suspension and the stabilized 76mm gun remained effective against North Korean and Chinese armor. The stabilizer technology that had impressed Weber so profoundly at Kummersdorf in March 1945 represented American understanding that small advantages accumulated through systematic engineering could produce decisive tactical benefits. The system did not revolutionize tank combat. It did not make Shermans invincible. It simply gave American crews a modest edge in the critical seconds between identifying a target and firing the first shot. In combat, where first shot hit probability often determined engagement outcomes, this modest edge mattered significantly. German tank designers had pursued different priorities throughout the war. They had created vehicles optimized for maximum performance in gun power and armor protection. Panthers and Tigers represented sophisticated engineering that squeezed extreme capabilities from available technology and materials. These tanks were genuinely superior to Allied counterparts in specific performance categories that German doctrine emphasized. But the doctrine and the equipment reflected German strategic circumstances and industrial limitations rather than universal principles of optimal tank design. American designers worked from different assumptions and priorities shaped by American strategic circumstances and industrial capabilities. They created tanks optimized for reliability, maintainability, and mass production rather than maximum theoretical performance. Sherman development reflected understanding that adequate equipment available in overwhelming quantities would defeat superior equipment available in insufficient numbers. The EZ-8 represented refinement of this philosophy rather than departure from it. The gun stabilizer embodied American engineering approach to military equipment, identify a real tactical problem that affected combat effectiveness. Develop a technological solution using available industrial capabilities. Implement the solution as standard equipment rather than experimental installation. Train crews to utilize the capability effectively. Refine the technology based on combat experience and production feedback. This systematic approach to incremental improvement produced equipment that worked reliably under field conditions, rather than achieving theoretical maximum performance that could not be sustained operationally. Weber's experience testing the captured EZ-8 taught him what many German military professionals had come to understand by war's end. Germany had been defeated not primarily by tactical failures or inadequate equipment designs, but by strategic circumstances and industrial disparities that made victory impossible, regardless of battlefield performance. German forces had fought with skill and courage. German equipment had demonstrated technical sophistication. German doctrine had evolved through combat experience. None of this mattered, strategically, when facing opponents with overwhelming material advantages. The gun stabilizer represented tangible evidence of American industrial sophistication that contradicted propaganda about crude mass production. The technology was not simple or easy to implement. It required precision manufacturing, quality materials, skilled assembly, and systematic testing. American factories had implemented all these requirements successfully while simultaneously producing thousands of tanks monthly. This combination of quality and quantity demonstrated industrial capacity that Germany could neither match nor counter. The psychological impact on German tankers who understood what they faced extended beyond immediate tactical concerns. These men had entered the war confident in their superior training, better equipment, and more experienced leadership. By 1945, extensive combat had systematically destroyed each of these assumptions. American tankers had received better training as the war progressed. American equipment had improved steadily while German equipment grew scarcer and less reliable. American tactical doctrine had evolved to exploit their advantages while minimizing German strengths. Former German tankers captured during the final months of the war and interviewed by American intelligence officers described the demoralization of facing endless Allied material superiority. They mentioned specifically the frustration of destroying American tanks only to face more the following day. They noted how American forces seemed unconcerned about tank losses because replacement vehicles arrived quickly. They observed that American crews operated with confidence, born from knowing they possessed adequate equipment and overwhelming numerical support. The stabilizer was mentioned occasionally in these prisoner interviews, though usually not by name. German tankers described American Shermans that fired accurately while moving, something German doctrine said was impossible. They noted with frustration how American tanks could engage during approach rather than stopping to aim. They acknowledged that this capability gave Americans tactical flexibility that German crews lacked. But the stabilizer was just one element among many that collectively demonstrated American advantages. The EZ-8 Weber tested at Kummersdorf represented the culmination of American tank development during World War II. Subsequent variants introduced minor modifications, but the M4A3E8 established the design standard that proved most successful. The combination of Ford GAA engine, HVSS suspension, 76mm gun, wet ammunition storage, and gyroscopic stabilization created a tank that balanced multiple requirements effectively without excelling in any single category. German tank development had followed different paths toward different objectives. The result was equipment like the Panther and Tiger that excelled in specific performance categories while accepting limitations in others. These tanks represented genuine engineering achievements that demonstrated German technical competence. They were not inferior designs. They were different designs reflecting different priorities and constraints. The American approach proved more effective under actual strategic circumstances of 1944 and 1945, but this did not make German equipment inherently flawed. The stabilizer specifically illustrated how technological sophistication could be applied to solve tactical problems without requiring revolutionary breakthroughs. Gyroscopic stabilization was not new technology. The principles had been understood for decades. But implementing the technology in tanks that functioned reliably under combat conditions required solving numerous practical problems related to manufacturing, integration, and operation. American engineers had solved these problems systematically. German engineers had not, despite understanding the PLEIF principles and recognizing the tactical value. The distinction mattered because it revealed fundamental differences in how American and German industries approached military equipment production. American factories emphasized manufacturability and standardization from initial design stages. Components were selected for availability and ease of manufacture rather than theoretical optimal performance. Systems were designed for field maintenance by mechanics with standard tools rather than requiring specialized facilities. Testing protocols identified problems early when corrections remained straightforward rather than discovering issues after production commitment. German military equipment development followed different patterns shaped by different industrial circumstances and military traditions. Designers pursued maximum performance within weight and size constraints. Complex components were accepted if they improved capabilities, even when they complicated manufacture. Field maintenance was assumed to occur at specialized facilities with trained technicians rather than at forward positions by unit mechanics. Testing often occurred simultaneously with initial production, leading to discoveries of problems after substantial production commitment. Neither approach was inherently superior absent strategic context. German methods produced excellent results when industrial capacity remained adequate and supply lines functioned reliably. American methods proved more robust under conditions of mass production and global logistics that characterized World War II in Europe and the Pacific. The stabilizer exemplified how American design priorities created equipment that worked adequately under realistic field conditions rather than achieving theoretical maximum performance that might degrade under operational stress. Weber survived the war and later provided detailed information to American intelligence services about Kummersdorf's testing programs. He described the systematic evaluation of captured Allied equipment and explained how German engineers had understood American and British capabilities clearly through direct examination. His testimony confirmed that German forces had not been defeated through ignorance of Allied equipment performance. They had known exactly what they faced and had documented it professionally. This knowledge simply could not compensate for strategic disadvantages that made defeat inevitable, regardless of tactical understanding. Steinmetz's comprehensive report on the M4A3E8 survived the war in fragments recovered from German archives. American technical intelligence teams who reviewed the surviving portions noted the thoroughness and professional objectivity of the German analysis. The evaluation had identified both strengths and weaknesses of the EZ-8 with accuracy that matched American testing results. German engineers had understood the stabilizer's tactical significance and had recognized the manufacturing sophistication required for reliable implementation. The captured EZ-8 that Weber tested eventually disappeared during Kummersdorf's evacuation in April 1945. Whether it was destroyed by retreating German forces, captured intact by advancing Soviet troops, or simply abandoned and later scrapped remains unknown. The tank had served its purpose as an educational tool, teaching German tankers about American capabilities, even as Germany's strategic situation deteriorated beyond any possibility of recovery. The lesson that the stabilizer taught extended far beyond its immediate tactical application. The technology demonstrated that American industrial capacity included not just mass production, but also sophisticated manufacturing of complex systems. This contradicted German propaganda that had consistently portrayed American equipment as crude and simple. German tankers who encountered EZ-8s in combat learned through direct experience that American engineering could be both sophisticated and producible at scale. The broader implication concerned the nature of industrial warfare as it had evolved by the mid-20th century. Military equipment had become sufficiently complex that industrial capacity determined strategic outcomes more than tactical skill or individual equipment superiority. The nation that could design adequate equipment and produce it in overwhelming quantities while maintaining quality standards would defeat opponents who produced superior equipment in insufficient numbers. American victory in World War II validated this principle thoroughly. The stabilizer represented just one small piece of evidence supporting this larger truth. German forces faced opponents with better logistics, more abundant supplies, superior air support, more effective intelligence, and growing tactical proficiency, in addition to numerical advantages in equipment. The stabilizer added one more capability to an already overwhelming Allied advantage. German tankers could study the technology, understand how it worked, and recognize its tactical value without being able to counter it effectively, given their deteriorating strategic situation. The personal impact on Weber and other German tankers who understood what they faced cannot be measured quantitatively, but shaped their experience of the war's final months. They recognized with uncomfortable clarity that they fought for a cause already lost against opponents whose material advantages made German defeat inevitable. This knowledge coexisted with professional duty and personal survival instincts that kept them fighting even when strategic outcomes were predetermined. The psychological burden of understanding the impossibility of victory while continuing to fight created stresses that extended beyond immediate physical dangers. German tanker accounts from the war's final months frequently describe the hopeless feeling of facing endless Allied material superiority. They mention destroying American tanks and watching more arrive the next day. They describe ammunition shortages that forced rationing of shots. They recall fuel shortages that immobilized vehicles. They remember watching Allied air power dominate the skies while German aircraft rarely appeared. The stabilizer was just one more element in this comprehensive litany of Allied advantages. Post-war analysis of World War II armored warfare confirmed what German professionals had understood through direct combat experience. Allied victory resulted primarily from industrial capacity and resource availability, rather than tactical innovation or equipment superiority. German tanks often demonstrated better individual performance in specific categories like armor protection and gun power. German crews frequently possessed superior training and experience compared to their opponents. But these advantages proved insufficient against overwhelming Allied material superiority, supported by effective logistics and air superiority. The M4A3E8 Sherman, with its gun stabilizer, represented the final evolution of American tank design philosophy during World War II. The EZ-8 was not the best possible tank that could have been designed with unlimited resources and no manufacturing constraints. It was the best tank that could be produced in adequate numbers using available industrial capacity while maintaining reliability under field conditions. This distinction mattered profoundly because it reflected realistic understanding of how military equipment functioned within strategic contexts, rather than isolated testing conditions. German tank designers had created vehicles optimized for different priorities within different constraints. The results demonstrated genuine engineering excellence that deserves recognition despite strategic failure. Panthers and Tigers were sophisticated weapons that reflected careful design and skilled manufacture. Their limitations stemmed from strategic circumstances and industrial constraints, rather than engineering incompetence. Under different strategic conditions with adequate resources, German tank designs might have proven more successful, but World War II was fought under actual rather than hypothetical conditions. The gun stabilizer specifically illuminated how accumulated small advantages could produce significant tactical benefits when implemented systematically across entire equipment inventories. The stabilizer did not revolutionize tank combat. Individual engagements between stabilizer-equipped Shermans and unstabilized Panthers might still favor the Panther depending on circumstances like crew skill, tactical situation, and terrain. But aggregated across thousands of tank engagements throughout Western Europe during 1944 and 1945, the stabilizer contributed measurably to American tactical effectiveness. The experience of testing the captured EZ-8 taught Weber and other German professionals that American engineering capabilities exceeded German propaganda claims. The United States could design sophisticated military equipment, manufacture it to consistent quality standards, produce it in enormous quantities, distribute it globally through effective logistics, and train personnel to operate it effectively. This comprehensive industrial and organizational capability ultimately determined World War II's outcome more than any individual weapon system or tactical innovation. The stabilizer represented tangible evidence that could not be dismissed or explained away through ideological assumptions. German engineers could examine the mechanism directly. They could disassemble components and measure manufacturing precision. They could test the system's functionality under various conditions. The physical reality of the technology contradicted propaganda about American industrial crudeness. This forced acknowledgement that German assessments of American capabilities had been fundamentally mistaken from the war's beginning. By the time Weber tested the EZ-8 in March 1945, strategic outcomes were no longer in doubt. Soviet forces were advancing through Prussia and Pomerania toward Berlin. American and British armies were crossing the Rhine and advancing into central Germany. German industrial capacity had collapsed under sustained strategic bombing. Fuel shortages immobilized remaining armored forces. Ammunition production could not sustain combat consumption rates. Trained personnel losses exceeded replacement capacity. The war was effectively over, even though fighting continued for another 2 months. Knowledge that American Shermans possessed working gun stabilizers mattered little in this strategic context. German tankers understood the technology's tactical significance but lacked resources to counter it effectively. The stabilizer became just another item on the comprehensive list of Allied advantages that German forces could observe and document without being able to overcome. Understanding how the technology worked and recognizing its battlefield value provided no path to strategic victory when fundamental material disadvantages had already determined the war's outcome. The story of the captured M4A3E8 at Kummersdorf parallels the broader German experience of World War II's final years. German military professionals understood clearly that they faced opponents with overwhelming material advantages. They documented these advantages professionally and comprehensively. They developed tactical responses that sometimes worked effectively in individual engagements, but tactical proficiency and professional competence could not overcome strategic disadvantages rooted in industrial capacity, resource availability, and alliance politics that had determined the war's trajectory long before Germany's final collapse. The gun stabilizer Weber examined so carefully represented American engineering philosophy applied to solving real tactical problems through systematic development and manufacturing excellence. The technology was neither miraculous nor revolutionary. It was simply effective, reliable, producible, and tactically advantageous. These qualities reflected the comprehensive approach to military equipment development that characterized American industrial mobilization during World War II. The result was weapons systems that worked adequately under field conditions and could be manufactured in quantities that overwhelmed opponents regardless of individual technical superiority. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.